Hello, my name is Aqilah Binti. Today I will talk about my topic, which is about the philosophy of probability. The objective in this chapter is to learn and understand the 5 philosophies of probability. Introduction of this chapter is the expected utility combines preferences and probabilities for rational choices in the face of uncertainty, quantifying satisfaction or value from various options. Probability judgment shapes daily life and underpins theoretical science, influencing both practical decisions and scientific pursuits. Has 2 interpretations. Subjective viewpoint, associate probabilities with the credences, or degrees of belief, of a specific individual. Objective viewpoint, associate probability with something that is independent of any individual. Objective view has 4 probability philosophy, which is classical, frequency, propensity, and logical and epistemic probability. Classical probability is to assign probabilities in the presence of evidence that is symmetrically balanced, the principle of indifference. Frequency probability is it defines probability using actual events, observations, or historical data. Propensity probability is the goal of interpretation was to solve the frequency problem and the inability to assign probability to a single case or experiment in interpretation. Logical and epistemic interpretation is a logical interpretation that tries to provide a framework for inductive logic. Subjective view only has 1 probability philosophy, which is subjective probability. Subjective probability is a measure of an individual's belief. It varies from person to person. The probability can change as a person learns new information, but probabilities are generated by suitable agents. Agents must be rational and logically consistent, with beliefs that satisfy the axioms of a probability calculus and adhere to Bayesian conditioning. Example of classical probability. What is the probability of getting an even number when you roll a dice? Dice side, 1, 2, 3, 4, 5, 6. Number of favorable outcomes to even is equals 3. Total number of outcomes equals 6. Calculation. Probability of getting an even number equals 3 divided by 6 equals 1 divided by 2. The probability of getting an even number is 1 divided by 2 or 0.5, indicating 50% chance of rolling even number. Example of frequency probability. If in a series of 50 coin flips, the number of heads observed is 30 and the number of tails observed is 20, we can calculate the relative frequencies or probabilities of getting heads or tails. Number of heads observed equals 30. Number of tails observed equals 20. Total number of flips equals 50. Calculation. Formula, relative frequency probability equals number of heads observed, total number of flips. Relative frequency probability of getting heads equals 30, 50. Relative frequency probability of getting heads equals 0.6 or 60%. Relative frequency probability of getting tails equals 20, 50. Relative frequency probability of getting tails equals 0.4 or 40%. The relative frequency probability of getting heads is 0.6 or 60%. The relative frequency probability of getting tails is 0.4 or 40%. Example of propensity probability. Assume you have a coin that is thought to be biased, which means it may not be fair and tends to land on heads more often than tails. According to popular belief, this coin has a 70% chance of landing on heads and a 30% chance of landing on tails. pH is the probability of landing on heads. PT is the probability of landing on tails. The popular belief suggests equals 0.7 pH equals 0.7 or 70% equals 0.3 PT equals 0.3 or 30%, since the probabilities of all possible outcomes must add up to 1 or 100%. Calculation. Probability of landing on heads equals 0.7 pH equals 0.7 or 70%. Probability of landing on tails equals 0.3 PT equals 0.3 or 30%. The popular belief is that a biased coin has a 70% chance of landing heads and 30% chance of landing tails, deviating from the equal probabilities assumed in a fair coin, where both outcomes have a 50% chance. Example of logical and epistemic probability. Logical probability. If we are told that at least 5 balls in the bag are red, we can calculate the logical probability of drawing a red ball. Logical probability of drawing a red ball equals number of red balls, known, total number of balls, unknown, equals 5, 10 equals 0.5 or 50%. Epistemic probability. Suppose an individual has some prior information suggesting that the bag might contain more red balls than blue. Given this information, the individual might estimate their epistemic probability of drawing a red ball is higher than the logical probability, say at 70%. The logical probability is 50%, while the individual's epistemic probability is estimated at 70%, influenced by their subjective beliefs or assessment of the situation. Example of subjective probability. What is your subjective estimation of the probability of encountering heavy traffic during your daily commute? Subjective probability of encountering heavy traffic equals 60%. This estimate is based on personal observations and experiences of traffic conditions during your regular commute, providing an estimate to guide your expectations or decision-making. Conclusion of this chapter is the interpretations of probability encompass various hypotheses and conceptual bases. The classical interpretation relies on the principle of indifference, assuming hypothetical symmetry and allowing for precise outcomes, but it faces ambiguity in its principle. Frequentist probability focuses on the frequency of occurrence, utilizing past data and reference classes but faces a circular definition issue. Propensity theory considers the degree of causal connection, relying on the present state of the system and allowing for precise outcomes, yet it encounters disputes over its concept. Logical and epistemic interpretations measure the degree of partial entailment, utilizing knowledge and intuition but may lack precision depending on the language used, striving to find the correct framework. Subjective probability assesses the degree of belief, balancing subjective and objective elements, permitting consideration for single cases but encountering challenges with reference class problems. Each interpretation brings its strengths and challenges to understanding probability. The end. Thank you.